Well, first of all, thank you all for coming. My name is Lawrence Kearney. I work for the University of Georgia. I'm kind of an SSSD expert, and my colleague is Mr. Mark Robinson. He is from the UK, and he will not admit it, but he is somewhat of an SSSD expert as well. He will play it down.
I will indeed. I'm just a glamorous assistant.
So what we're going to do today, wow, I've never actually had one of these. It instills a certain amount of confidence, I must admit.
Come on, get over it.
Yeah. Anyway, carrying on. What I would like to do is, I've been talking about SSSD for several years. I have found, for the most part, the problem people have with it, system administrators, is at the conceptual level. You know, they just don't understand how it's put together and how it's supposed to work. So I'm going to spend a few minutes going over SSSD concepts so that you guys can get those down. We'll field any questions about that in real time. I'd like this to be as interactive as possible. I could go through the slide deck through the rest of the presentation as need be, but what I would rather do is, once you guys get the concepts explained and you start to form your questions, let's start talking about it so we can start doing things, showing you things that you can use when you get home and actually start working with this stuff. And hopefully we can help you do that. So formally, just so I can say that it's announced, this session is the System Security Services Daemon SSSD, which is actually pronounced
Triple SD. It's much easier. Fewer syllables. And you know when to stop.
Yes. For SLES 12 and Active Directory. And we're going to focus on the Active Directory backend now, but time permitted, we do not have to limit our conversation to that. So that said, oh, there it is. There's the clicky bit. Let's see if it works. Outstanding.
Yay.
Welcome to Triple SD 101. So we're going to start here. So basically, the primary advantages of Triple SD, well, the needs that it's really, I'm sorry, I've gone off task already. We're going to talk about why you would want to use Triple SD, the needs that it addresses. Thank you, the needs that it addresses, and learn to understand the concepts. Thank you, Mr. Robinson. So, first of all, the needs being addressed are legacy PAM infrastructures are getting, they're complex to manage, and they don't really do everything we need to do. They have some significant shortcomings. And LDAP and Active Directory backends, LDAP backends and authentication backends in general are proliferating due to special needs. So the traditional Linux authentication infrastructure doesn't fit well into this very granular authentication ecosystem, for lack of a better word. And most of them actually do not have any real offline authentication, and that's one of the primary benefits of Triple SD, besides Linux servers being limited to really one remote backend for authentication. And just out of curiosity, a quick straw poll, how many people have actually tried to implement Triple SD? Okay. Successfully. Outstanding. How much trouble did you have?
It got difficult. We had about 2,000 active user accounts we used for external FTP accounts. And that was it's bread and butter of our business. We had to really make sure we got all of the stuff set up correctly in Active Directory to have very granular level rights. It's more difficult to work from my Windows AD admins versus getting SSD rolled up. Once I got it in all the groups and all these nested arrays, then okay, look at Active Directory and like,
there you go.
Okay. And this is a question kind of speaking forward, but are you using POSIX attributes in Active Directory, or are you allowing the daemon to just dynamically map UIDs and GIDs?
because the GIDs had to bring in Active Directory.
And because there was a file system component is tied to it as well, I would assume. Exactly. That's a very important design conversation that. Perfect. And we really want to discuss that use case because it would be beneficial to other people in the room as well. So let's see. So basically, modern Linux infrastructures are getting more capable, and the Triple SD authentication service really helps Linux participate in more complex authentication infrastructures. Very tight Active Directory integration is really mission critical these days. And I'm going to attempt to show you the level of that integration which is capable with the Active Directory provider. So we'll look through some log files and actually demonstrate that. It's really quite remarkable. I will use the term several times that a Linux server running the Active Directory provider from SSSD approaches near domain member capabilities as far as being able to utilize Active Directory. It's sweet. And all of that, you get more pudding in your bowl, and it's less complex. So what I really like is bolded, and that's kind of what I wanted to bring to you guys. Multiple concurrently available identity stores. The traditional Linux authentication infrastructure has been you can authenticate locally, you can authenticate to one remote source. Whether it be with LDAP or Kerberos, it can be highly available, it can be load balanced, but you're limited to one remote source. The nice thing about one of the nicest things about SSSD is you can authenticate to multiple remote stores concurrently, and it provides you with a mechanism for handling ID collisions. It's really fantastic. The tight Active Directory integration we were just talking about, a single configuration file. And I don't know what is on my next slide. I'm going to attempt a slide machine swap out on you. We'll see how it works. And I showed this in the hands-on as well. Oh, that didn't show us anything worthwhile, did it? That's what we wanted. So when you start talking about Active Directory integration and connectivity, and you start talking about file shares and just general communication between a Linux box and an Active Directory environment, this is what you're talking about managing per server. You know, that's a lot of configuration management workload. It's a lot of complexity, and it's not as feature-rich as the SSSD client, and that's really the crux of it. It's so much simpler, and you get so much more. See if I can be taught. Possibly not. Uh-oh. Now I've done it. Let's try that.
Yep, there you go.
Oh, well, I've pressed another button,
no.
So.
You had it.
I had it. There we go. So that brings us to the single configuration file. This isn't highlighted, but I do want to bring it up. The SSSD caching capabilities are really very elegant, and we will have the opportunity to talk about that. And the functional benefit of that is that it reduces the load on the authentication backend that you're talking to, and it reduces the load on the server seeking the authentication. Yes?
Unless you have slow disks locally, or people remember that. We've had to build all of our caching stores on RAM drive.
That seems a little unusual. I want to talk to you about that. I would suspect that how you're searching the directory is probably the issue there. I would have to ask, do you have enumeration true or false? And see, we're already getting into the technical bits. This is really where I would like to go. And we'll actually talk about that in a moment as well. Okay, because basically the function of enumeration when you start talking about LDAP connectivity, and I'm assuming you're using the LDAP provider. Is that correct? The concept of enumeration is when you set enumeration to true, you're basically saying everything you can see in the directory, cache. If you can see it, cache it. That's a lot of information, even for something that only contains about 2,000 objects, especially with the refresh cycle and all of the caching work going on. If you set enumeration to false, that basically puts the daemon in a cache on query mode. So basically, unless I ask you for it, don't cache it. And I have seen, the behavior I've seen when enumeration is set to true is basically the daemon is constantly caching. The entire time it's running, it's constantly caching. And I've even seen on larger directory service environments, IDs cycle in and out of the cache because the daemon only has so much cache it's configured with by default. So basically, if you're caching tens of thousands of objects constantly, eventually the object you're looking for cycles out of cache and it's not available. So I would be willing to bet that enumeration is set to true for you, but do check. And I almost tripped over my own cord. And part of the reason why that cache is so important is because it provides you your true offline authentication. So basically, if your Active Directory backend that contains a user goes offline, unless their password has changed in the period of time between when it went offline and when it was cached, those users are still going to be able to log in and do stuff.
How long does the cache last?
The default for refresh is 90 minutes.
But let's say you get disconnected.
Now, see, now they're doing it.
It's like, how long can a machine operate it and not get disconnected?
Oh, it can operate indefinitely in a disconnected state. Yeah, I mean, if the authentication source goes offline, the system will not actually attempt to do anything with the cache until the system comes back on, until the authentication store comes back online.
And when we're talking about offline, we might mean taking a laptop away from the network.
Exactly.
Not the back end necessarily going down and becoming unreachable. It could be that we take the client machine away with us somewhere.
And one of the problems that we've had with our current directory authentication stuff is a machine will lose connectivity, something on the network, just it can't talk to the main controllers, and it just loses it doesn't know anything anymore. And then about 30 days later, as the cache expires, it gets wiped out, and then the services go down, and people can't log in anymore, and all sorts of.
Yep, and this is exactly the kind of stuff that I'd like to help you guys with. I mean, like I said, we can run through, I want to get through a few slides, but we can run through slides for the rest of the session, or we can actually just kind of make it a working session, and get some work done, so to speak. And the other bit to mention about offline authentication is the only time that the daemon will actually go to cache for authentication is when the backend is detected to be offline. So that's kind of a security component that you need to be aware of, because whenever you start talking about caching credentials, people have all types of questions. But they purposely designed it to be as secure as possible. They intentionally designed it to be as secure as possible. So the daemon does not go to cache to authenticate a user unless the actual authentication source is offline. So you have three concepts you really need to understand. This is going to be old hat for you, obviously. This gentleman was in our hands-on session as well. There are three pillar concepts you need to understand for SSSD. Most Linux administrators are used to a linear configuration path, with the massive files that we saw previously. SSSD operates more like a modular authentication service, and it uses the three concepts of providers, responders, and authentication domains. If you can think through setting up a Linux server to authenticate via LDAP, you're basically going to load a module, pam_.so, right? You're going to put directives within the etc ldap.conf that module understands and can use to communicate with an LDAP backend. LDAP URI, certificate, LDAP proxy user. Well, if you can consider the pam_ldap.so module and the command directives and the configuration directives to use it, that is the concept of a provider. And where SSSD differs from that model is SSSD provides more providers for you to use against a backend. So as opposed to, for instance, just the SSSD LDAP provider, which you could kind of functionally equate to the pam_ldap provider. I'll just use the word provider. That would be a pretty good one-to-one mapping for functionality. Linux also provides a Kerberos module so that you can authenticate via Kerberos. And of course, you put configuration directives within the ldap.conf file that are specific to the pam_krb5.so module, which would be a Kerberos provider if you think about it in that context. SSSD provides LDAP and Kerberos providers as well. It also provides a range of other providers, including a dedicated Active Directory provider. So that's the concept of providers. The concept of responders is it is kind of a gateway module. Well, I'll back up a step. The two responders we'll talk about for the sake of concept are the PAM responder and the NSS responder. Does anyone know what the NSS framework does on a Linux box? All POSIX really cares about is a UID and a GID. Kind of like the internet. The internet doesn't care about DNS names. DNS names are for us. Things are routed across the internet using IP addresses. It's kind of the same thing with POSIX. They don't care about names. They only care about UIDs and GIDs. The name service switch framework resolves usernames and group names with UIDs and GIDs. So when I give you a UID of 601, I mean this user. So that's what NSS does. The PAM framework, which stands for Pluggable Authentication Modules, is exactly that. Once a name is resolved, the PAM stack basically explains what a name can do. And it can be as simple as, is a name given allowed to authenticate? And if that name is allowed to authenticate, how is that user allowed to authenticate? So that's basically what the PAM stack and the NSS stack does on Linux. The NSS and PAM responders for SSSD intercept calls that go to NSS and PAM. They implement SSSD features and communicate with PAM on the back end as needed. Think of it as kind of a gateway for PAM and NSS. And an example of that would be, for instance, most PAM modules, I would be willing to bet nearly all, do not understand case insensitivity, right, on Linux. So part of the NSS feature, part of the SSSD specific feature set that would be implemented by the NSS responder is to implement case insensitivity for names. So you could give it a case insensitive name, the NSS responder would understand it, things would move forward, and it would communicate with PAM on the back end as needed. And all that you have to do to utilize a specific responder is specify it within the SSSD.conf file. And we'll walk through that as well. And that takes us to the final concept of authentication domains. The SSSD uses a single configuration file which will contain the domains, the SSSD domains, it will process for authentication services. It contains the responders it's going to load, and it will contain a labeled configuration stanza for each domain or each identity store that it's going to look to for user information to search and authenticate. And it will search through those in the order that those authentication domains are given. Technically, the only thing that's required to have a valid SSSD authentication domain is a configured identity provider, which you can kind of guess from our discussion now has to do with getting names, and an authentication provider, which of course has to do with how that name is going to authenticate. And we'll look at some SSSD configuration files to help solidify those concepts. But basically, once again, to sort of review, the three concepts being providers, and from my previous statement, not only will you have LDAP providers, Kerberos providers, Active Directory providers, you will also have identity providers, authentication providers, and other service providers. And it's my understanding that that's why people do have an issue with SSSD is it's not complicated, it's conceptually different. It's actually really elegant and useful. It's just conceptually different. And once you can get your head around those concepts, you've got it, you're done. So that said, I'll move on to the next slide, and that's basically what this is explaining. And I won't focus on it because you've pretty much gotten the lecture, so to speak. That was actually kind of a nice pun. Or maybe it wasn't.
Carry on.
Very good. So for instance, the SSSD provider in this case is libSSS_LDAP.so. So this provider is going to respond to command directives put in the SSSD.conf file that are specific to it. And I'm going to pause right there. Do I have glasses? In fact, I do. Wonderful. And we're going to take a quick look at that. Let's see if I can do this right. Yay. Success. So, everyone's familiar with using man files, right? Okay, so let's say that I've decided I want to use an LDAP provider because I want to use LDAP to connect to an Active Directory backend. I would recommend using the Active Directory provider because it's so much better, and we'll certainly discuss that. But let's say you're going to use the LDAP provider. You'll need an identity provider. If you're just going to look up names, that's all you need. But if you're going to authenticate via LDAP, you'll also need an authentication provider. So within your SSSD.conf, you would specify ID provider equals LDAP. Authentication provider equals LDAP. Well, if you, like with all LDAP configurations, you have to configure it. So you'll need to know what configuration directives to use to actually configure that domain to actually talk to Active Directory via LDAP. So using your standard man files convention and the help files for the SSSD, use the same format. SSSD, we'll start with man, dash LDAP. And that's where you would go for help. LDAP URI, backup URI, you're starting to see the pretty kind of standard stuff that you would use if you were connecting anything to connect to LDAP. Taking that a step further, let's say that you wanted to use the LDAP identity provider and the Kerberos authentication provider to search and authenticate against Active Directory, because you can actually mix those two providers. You're starting to see the benefit of the modular provider model, because once you know what a provider is and how it works, you can combine them for whatever use case that you need. So you would, using the same convention, if you were going to use the SSSD Kerberos authentication provider, you would specify an ID provider equals LDAP, authentication provider equals KRB5. And of course, then you need to know how to configure the Kerberos directives. Oh, I don't have the Kerberos provider installed on this laptop. Forgive me, that was a demo faux pas. But rest assured, it would work if I had the Kerberos provider installed. And that's actually a very good lesson. You're not going to get the man files for providers you don't have installed. However, I do have the Active Directory provider installed. So what would I do? I have no prizes or anything to give out. You're just on your own. Not so bad once you just get your head around it, right? So, going back, oh, the graphic is on my screen, not on yours. So going back to here, so this is typically this is the specific module you're going to load, and now you understand how to configure it. Well, now you understand the basics of how to configure it. Hopefully we'll go into it with some more depth. So, since you're using LDAP and you're going to look up users, you're also going to need to invoke the NSS responder, right? And the actual daemon itself, I didn't discuss this as one of the core concepts, but it's just a daemon concept to understand. The providers loaded and the responders will instantiate their own worker threads within the Linux process table. The actual SSSD daemon itself is a parent daemon to all of those processes. And part of its responsibility is as a monitor process, similar to the old System 5 initd process is, when it detects a process that's crashed, it's its responsibility to restart it. That's not like initd, excuse me. Just the parent-child relationship is the same as initd. But that is the responsibility of the monitor process, is to actually monitor the child processes and restart them if they crash. I keep trying to trip over that cord. There we go. Oh, I have a clicker. So, this kind of gives you an idea of the range of providers that you have to configure. And again, I hope now that the concept of providers is clear, how to use them and how to look for help configuring them, I hope that's helpful. So, of importance to us, for the sake of this talk, is the AD provider. Also notice that you have AutoFS and pseudo providers. Not only is the daemon capable of processing requests and caching user and group information for providers, it can also cache specific service information like AutoFS and pseudo, which is very handy. And of course, even though it's a service, the concept for the provider is exactly the same. So let's see. You don't need to know that much about IPM and IDM backends. I'd rather actually get to the functional part of the discussion if we can just carry on. So, and this takes us basically to the same range of responders. So these are the responders that you can invoke to configure as well. Mostly, what most of you will probably be using will be the NSS and PAM. The AutoFS and pseudo they're not difficult to configure, but there's not a lot of people that have that use case. So users and groups are probably going to be your focus.
Question at the back, Lawrence.
Oh, yes.
Does this functionality for like AutoFS, does it replace the traditional AutoFS daemon, or is it a complement to it?
Oh, no, it does actually replace it. In a nutshell, the current version of SSSD, currently the AutoFS providers does not have an AD option for it. So the only valid value for the AutoFS provider is LDAP. And that brings up an interesting model where, once again, you kind of have to learn use what you've learned to understand today. If there is not an AD value for the AutoFS provider, if you have to use LDAP, then you have to load the supporting LDAP provider modules, and well, not modules, but the command directives within the SSSD authentication domain to support it. So for instance, if you're using an LDAP value for the provider, what do you have to do when you're configuring an LDAP, an SSSD domain that uses the LDAP identity and authentication providers? You have to provide you have to provide a schema type, you have to provide a URI, you have to provide an LDAP server. So that's kind of understanding that when you say provider equals LDAP, that means that you need the command directives, or really the configuration directives, in your comp file to support that provider. So the next versions, I would be willing to bet that the next version on SLES, because I know the versions of SSSD in the wild support an AD provider for AutoFS. So it's only a matter of time until it bubbles down to the SLES stack. But that's a very good point to bring up, and I just wanted to let you know that you can do it. You have to use the LDAP provider to do it, and if you use the LDAP provider, it doesn't share the configuration directives with the Active Directory provider values. So you'll have to configure them both.
And the same for sudo.
And the same for sudo. That is absolutely correct. So, and to further answer your question, essentially, at the university, I do centrally manage our AutoFS maps in LDAP as well. So I do not use a local configuration at all. I keep all of my AutoFS maps in LDAP, well, in Active Directory, and read them via LDAP because I have to use the LDAP value for the AutoFS provider. And I cache those down to the Linux servers as well, because our NFS sources that are providing the mount points that are used by AutoFS are not the same as Active Directory. So because all of the maps are cached, if I lose my connectivity to Active Directory, it doesn't matter because the maps are cached and the NFS sources are still online. So, I mean, very rarely will your file system provider and your authentication provider be the same in large environments. So having those maps cached is another security blanket with LDAP. You know, if the LDAP server were down and I were reading them in real time via LDAP and not caching them, when the LDAP server was down, my maps would not be available either. And it's the same thing for pseudo rules as well. The same type of rationale. Oh, I'm sorry. This is one of the bits we wanted to get to. This is the SSSD configuration file. This is a very simple example. The top section, it uses an INI file format, very intuitive to use. The top section is considered the global monitor section. You know, you configure things that apply to the daemon. One of those things being services. This is where you would configure responders. So for instance, for the services section, if I were just searching for and authenticating users, I know I need the NSS responder, and I know I need the PAM responder. So for that configuration directive, I would just specify NSS, PAM. Done. The only other thing I have to do when I come down to the rest of the global section is I have to add a little section with the square brackets for NSS and PAM. And I've put those on the same line to save space on the slide, but they would actually be on their own lines. And it's no more difficult than that to configure a responder. So when the daemon comes up, it's going to read the services, see it has a configuration stanza for that responder, and simply load it. Done. There's nothing else for you to do. And you can specify command directives for responders as well. And you can find those in the, if you man sssd.conf, you'll find the configuration directives for the things in the global section. I mean, you're kind of starting to put together, once you know how it works, it's not that difficult. It's not rocket science. You can specify configuration directives for the responders. In this particular example, the reconnection underscore retries, for the longest time I associated that with SSH, because that's what you see in the etc sshd underscore config file. But this actually refers to the number of times the monitor is going to attempt to restart the responder if it crashes. And I usually do use the filter users for the PAM responder because I don't necessarily want my local users and groups, you know, daemons, root accounts, things like that. There's no reason for the daemon to return those in a search. So I always use the filter users directives. I use the filter user directive as well. And this is a typical SSSD domain configuration. And like I said, minimally, you just have to specify an ID provider. In this case, it's going to be AD. An authentication provider. In this case, it's going to be AD. Done. And the nice thing about the AD provider, you can specify the AD server, you can specify multiple AD servers, you can specify other directives, but if your machine is synchronizing time with the domain, once again, just like any other member domain server would, if your machine is participating in the DNS space for the domain, again, like any other member domain server would, and you join the system to the domain using the standard Linux tools and the SSSD AD provider is running, it's going to use the same service discovery facilities as any other domain member server. It's going to discover the domain information via DNS, and it's going to cache it, and it's going to use it. And I'll give you an example of that. Let's see if I can successfully change machines again. Success? Maybe not.
For small values of success.
I know, right? All right, we'll try this again. All right, good. We're back to where we started. That's always a plus. Yes. And this is actually a presentation I gave for the University of Georgia weeks ago. It just has some information that's not in the SUSE slide deck, but it's functionally relevant to what we're talking about, so I wanted to show it to you. So, if we move down a bit. So, this is a stanza from out of the SSSD log file. And I just have the AD provider configured, just the AD provider, just the identity provider and the authentication provider. And I have the machine joined to the domain. It's participating in the DNS namespace for the domain and synchronizing time with the domain. The SSSD stack has discovered discovered the domain name, the flat name, discovered the site, discovered the forest, discovered the DCs that are available, established some of them as primaries, some of them as secondaries. When one of those DCs goes down, when the primary DC it's using goes down, just like any other member domain server, it's just going to connect to another one that it's discovered. And this is without configuring any static server information or anything within the configuration file. That's what you're getting by joining system to the domain and using the Active Directory provider. The LDAP provider, of course, doesn't get this granular because LDAP is it. You can only configure LDAP to a certain point. Usually it's a functional point, and you're never going to equal the security of the directory. And, well, you're never going to equal the security of the directory that you're connecting to. You're only going to get a basic functional connection that was where you were okay with stopping because it worked, so to speak. And that takes us kind of to security as well. The SSSD stack is actually sophisticated enough to use Active Directory GPOs for access to the host. That's pretty remarkable.
So
yes.
Can I just chip in one thing about, we talked about NTP there, time sync. You're familiar with configuring ntp.conf, I would think. Can you use your server directives? Oh. Don't do that. In the modern versions of NTP that understand the pool directive, you can use pool and the DNS domain name of your AD domain. So uga.edu, and it will then query DNS for domain controllers and automatically use those for NTP. So it's one line, pool, DNS domain name.
How awesome is that? So let's also look at a configuration file. How about that? Let's actually look at a production configuration file. If I got a blank screen, there we go. Let's just go here. Let's see what we have. I think I put some in downloads. Indeed, I did. So let's look at one that contains an AutoFS stanza. For instance, like the one we're using at UGA. And do you know how to increase this font size, Mark? Because I would like everyone to be able to see it better. This is gedit. I have no idea, I'm afraid.
We close that down, open it in the terminal instead.
Oh, can you?
You close that.
All right.
Right-click in there. No, in the terminal.
Yeah.
That's it. Open in terminal. And just use less.
And just use less?
That
Very
would
good.
be
Will
easier.
do. Indeed. Let's go ahead and just maximize that. And Control-Shift should be able to just plus that. Yeah. Very good. Is that better? Can you guys see that all right?
Yep. Looks good.
Okay. There we go. All right. So I'm actually going to have a seat. I hope you guys don't mind. So let's walk through this configuration file. So this is just a standard stanza. You'll never have to configure that. Once again, we're talking about configuring the global section for the monitor, for the actual daemon itself. And I'm actually going to quit this and just show you real quick. Right, man, once again, since we're talking about configuring the monitor, and there's our help for that. So just to kind of demonstrate that. Let's go back to where we were. So once again, in the services section, once again, this is where we're going to configure responders. So we're simply going to list them with a comma delimited list. I'm going to search for users. I'm going to authenticate users, and I want to also cache AutoFS maps. So that means I need the NSS responder, the PAM responder, and the AutoFS responder. I'm only connecting to one domain. If I were connecting to multiple domains, if I were going to have multiple SSSD authentication domains, this would be a comma delimited list of those authentication domains. It's also important to understand that this is also the search order for those domains. So if I were to say, for example's sake, have 3 domains called LDAP1, LDAP2, LDAP3. Let's say I have the same user, user1, in all of those LDAP backends. They're different, but the same user exists. If I go to log into the Linux server using a shell session, and I just specify user1, And I'm going to go ahead and use the term because I'll explain it in just a moment. That's an unqualified user. I'm just going to say user 1. What the daemon is going to do is it's also going to use that domain list as the search order for the domains it's going to look for users. So it's going to go to LDAP1, and if it finds user 1 in the LDAP1 domain, those are the credentials it's going to expect. If I'm actually trying to log in as user 1 at LDAP2, then I'm never going to get the right password if those passwords are different. However, and that is what's referred to as a simple ID collision, right? However, if I want to log in as user 1 at LDAP2, part of the reason why I use the term SSSD domain is because that is a label you give it, and that is the label that the daemon uses for the domain. So if I fully qualify the SSSD user, I just say user 1 at LDAP2. And then it's going to bypass the search order, and it's going to search for the user and expect the credentials for the user 1 account in the LDAP2 LDAP tree. So if you have an ID collision, the only thing you have to do to resolve it is fully qualify the user using the SSSD domain name. The only place where that breaks down is with Active Directory. Active Directory, the SSSD domain name for Active Directory environments have to be the same as the fully qualified Active Directory domain name. So in our case, our Active Directory domain at UGA is msmyid.uga.edu. So therefore, the configuration stanza for my SSSD domain also has to have the name msmyid at uga.edu. Now, if you have large Active Directory environments that have subdomains, that doesn't pose a problem because you can just specify subdomains as different authentication domains because they are in fact different and there won't be a name collision. However, if you have multiple Active Directory domains, once again, there's still not a potential for collision because those fully qualified domain names are going to be different as well. But I just want to let you know that that's the only time the SSSD domain name is not open-ended, is when it's an Active Directory domain that you're using the Active Directory provider for. If you're connecting to an Active Directory environment using the LDAP providers, then once again, it's open-ended. You can call it anything you like.
10 minutes.
10 minutes? Okay, let's go through this file pretty quickly. And that won't take long because I do want to take some questions because pretty much we've gone through all of the concepts. So once again, this is how I complete the invocation of my NSS responder. Is I just specify it within square brackets like I would in an INI file. And I'm also specifying some configuration directives for it, and I am filtering for users. So these are simply users that the NSS responder is going to ignore when a search is performed. I've done the same thing for the PAM responder. I've simply specified a reconnection directive, limitation really. And I've specified the AutoFS responder. I'm not providing any other configuration directives for the responder, so simply listing it like this invokes the responder when the daemon starts. That takes us to our domain. So you notice that the domain has the same name as the Active Directory domain because of the naming constraint with the AD provider that I just described. If I were not doing, if I were not doing either of these things, so specifying LDAP providers for AutoFS and access, the only thing I would technically need, oh, I'm sorry. This is not actually using the Active Directory provider, forgive me.
Nope.
Whoops.
Wrong file.
Wrong file. However, if I were using the Active Directory provider, the only thing I would technically need in this file would be ID provider equals AD, authentication provider equals AD. And if my machine were joined to the domain, done.
And how would you recommend joining the machine to the domain?
I would recommend joining the machine to the domain using YAST, using the domain membership module. Very straightforward and easy. If the packages you're required to do it aren't installed, YAST will automatically install them, and you just specify the basic domain information. Excuse the cough. However, going back to your point, because I am using the AutoFS provider, we're just kind of pretending that everything else is AD. Because I am using the AutoFS provider, thank you, sir. And it is set to LDAP, I actually need to specify the LDAP directives to support it. And specifically, the LDAP URI, so what LDAP server to talk to, how to bind to it, and the AutoFS specific, excuse me again, LDAP information. That was horrible.
Morning.
Sorry, we're all awake now, right?
Question at the front?
Yes.
Comment more than anything for the benefit of the group. When you're just getting started with this stuff, and if it doesn't work, I think it's figuring out why it doesn't work is kind of tricky, right? So that debuggable comment there,
Yes.
comes in really handy because it's very verbose. You have to think through it. I would just caution you all: do not leave it set that way for very long. It'll destroy the machine.
And just like anything else, the easiest thing to troubleshoot is something that is completely not working, right? I can be taught.
I can mute you.
So if the daemon isn't starting, your range of debug for the daemon is 0 to 9, basically 1 through 10, right? I've never had to go above 7 in order to troubleshoot a daemon. Everything above 7 is more programmatic information. It's not, if I'm finding what's wrong at that level, it's probably not something I can fix. Honestly, just saying. So the intuitiveness of the logging level for this daemon is so good. If the daemon is not starting, set the debug level to 7, try to start the daemon, go to the last 10 lines of the log file. It will tell you exactly what's wrong. I've never not been able to solve a problem this way. It's fantastic. Before I go any further, questions, I want you guys to have a chance. Yes?
For the filter directive you had above, is there kind of wildcard to filter all local users, or do I have to specify all my local users?
I don't know of a way to specify all local users. You do actually have to list them. And that's very common, like the old LDAP, NSS configuration directives for the NSLCD. You actually had to list users and groups that you didn't want the daemon to return in a search. This is exactly the same thing.
If I have, how can I specify I want first local authentication and then authentication against Active Directory and stuff like that?
That is actually the default. So local users, if there's an ID collision between a local, thank you, that was a very good question. If there's an ID collision between a local user and a local group, the local user or group will always take precedence.
As per the NSS switch.com.
Exactly. And that is a behavior you can change, but it depends on your use case. But local users always take precedence over remote users. Oh, come on, that was awesome. Anyone else?
If you allow me to play telephone, the manager sent me a bunch of questions.
Oh, please, go ahead.
So,
Awesome remote questions. They're not even here.
the first thing was extra equipment or servers required. Just in case.
No.
Didn't think so.
The SSSD stack is pretty much available on every respectable Linux distribution out there. And I use the term respectable loosely.
The only thing to watch out for with that is that you do not have the AD provider in the SLES 11 distribution. You have to use the Kerberos and LDAP stack together, much like this kind of thing we've got on screen now. So the AD provider is 12 onwards, and CentOS.
And almost every other platform except SLES 11.
Yep.
And
Sure.
How are they working with Microsoft? Is Microsoft open and helping development? Or are they still closed source and all this SSSD bit is a product of reverse engineering?
Okay, I will give you the answer to that. There is a project out there, and this actually goes back to the slide we completely avoided. So there's an open source project out there called FreeIPA. FreeIPA stands for Identity Policy and Audit. It's intended to be a heterogeneous platform for security, auditing, and configuration management across Apple, Linux, and Windows systems. The Red Hat originally saw the shortcomings of the PAM, LDAP, and Kerberos stack, for Linux and its placement in the workspace. Because let's face it, when Linux can authenticate to multiple backends concurrently, it's a much better federation candidate. I mean, it's a great application platform regardless, but federation, not such a contender. So that said, Red Hat approached the folks at the FreeIPA project, told them, because, well, I'll back up to what FreeIPA actually is. It's basically an Active Directory implementation for Linux, really is what it comes down to. It's actually sophisticated enough that you can establish bidirectional trusts between Active Directory environments with it, and Linux can hook into it. There is an IPA client for Linux systems so that it can participate in those relationships. Red Hat told the folks at the FreeIPA project that they would give them 2 full-time developers for their project if they got a thinner client back for their platform, and that's what SSSD is. So it's actually the development capabilities of the folks at FreeIPA that are responsible for the high level of integration. And all of the reverse engineering, how much they're working with Microsoft, I don't know. But I wouldn't be surprised if they were at some level. Does that make sense?
Yep, that makes sense, and I think that's all his questions.
Oh, outstanding. Yes?
One's a working question, one's a what's next. So I've gone through SLES 12, the Active Directory, GAS module to join my domain. Join's fine. My Active Directory administrator is created with the POSIX extensions, users with extended attributes of UID, GID. However, when I try to log in with that user, I don't inherit that UID, GID from Active Directory. It creates that, that range of UID, GID that you specify in YAS. It picks out of that range instead of pulling out the UID, GID from Active Directory.
So have you configured SSSD for the AD provider?
I haven't touched any files except for YAS.
So
that's what I'm missing.
That's the bit you're missing there, is it's using the Kerberos client kind of stack to authenticate and then generating you a UID, GID on the fly.
Which is specified in the Kerberos client configuration file. Okay. Exactly.
Yeah. So moving to this with the AD providers would be enough to get that information out of your directory.
And that does actually bring something forward as well. You have 2 ways of getting mapped UIDs and UIDs. And I know I'm extremely short on time. So basically, if you're storing your POSIX attributes within Active Directory, a non-mapped configuration would be you have the daemon configured to read those POSIX attributes from Active Directory. If you're using a mapped configuration, you're allowing the daemon to generate UIDs and GIDs on the fly. And that's a very good way to do it, but the thing to understand is that mapped ID configurations and non-mapped ID configurations are completely incompatible, especially when you throw in file systems like this gentleman was talking about. They're pulling attributes from Active Directory, reading them in the daemon. That's how their POSIX users are getting their UIDs and GIDs, and those marry with components on the file system.
The second half of that, though, is Microsoft says they're removing the identity management for Unix platform in Server 2016 and will no longer be supported. How are we going to go forward after that point?
That is actually not going to be a problem for you. I don't know if they're updating the POSIX schema with Windows 2016. I don't know the answer to that. What I do know is ever since Windows 2003, and Sandra, correct me if I'm wrong, it might have been Windows 2000, the NIS schema extensions have been included. Previously, when you installed identity management services for Unix, the actual schema was extended to support the NIS attributes. With Windows 2008 and above, the POSIX schema, the NIS schema, was already there. When you installed the identity management for Unix role on a Windows 2008 server, all it basically did was install the plugins for the MMC so that you could manage them in a GUI. Yes?
You have 1 minute left.
Thank you for. Oh, thank you, Sandra. Sandra's going. You people need to go.
So the short answer is the schema will be there, but you'll have to populate it.
Exactly. What they're dropping, they're stopping development for the identity management for services role, which means you won't be able to manage them with the MMC, but the schema will still be there. That means you'll need some type of out-of-band IDM management service to actually do it.
Okay, one very last question.
Yes.
Very quick question.
Is related to UIDGRP. One of the things about Unix is when you create user, normally the name and the group are the same. Let's say Oracle group, Oracle user, Oracle group. And one of the problems we have run into is that Microsoft AD doesn't write the username and the name is the same. And
yes.
Anybody run into that issue, and how do you use that?
How I resolve that is I use custom attributes. And one of the nice things about SSSD, that's actually a lot of fantastic questions. I'm so glad we did this way. I will install custom attributes within Active Directory for those classes of users that I can provide any value for I want. And then I will map that attribute to the custom attribute in the SSSD configuration file. So for instance, if I have my AD domain configured, say that the group name is CN as far as Active Directory is concerned. I don't know if that's technically correct, but let's just work with the example. I can say LDAP group name equals extension attribute or whatever custom attribute I've specified. And that will map the existing Active Directory attribute to the custom attribute that I have, which just has the string for the group name that I want. So therefore, my username in Active Directory can be the same. And since it's a custom attribute that Active Directory isn't monitoring at all, the Linux server will just read the string I've configured. And therefore, as far as the Linux server is concerned, my username and my group name are the same. And Active Directory is happy as well. Does that help? And actually, you can see that. Let me actually show you. Oh, yes, I know. Saunders, I thought I had a mapping here real quick.
He's staring at us, Lawrence.
Could you otherwise state your questions?
Yes, I can. Thank you, Saunders. We're all done.
Yep.
Yes, my letter.
Yes, okay. Come.
So, thank you very much.